Today, we're tackling a problem that asks us to find the smallest number in an array, then calculate the sum of its digits. The final twist: we need to tell if that sum is even or odd. Sounds simple, but let's see how efficiently we can do it. Given an array of positive integers, our task is to first identify the minimum value within that array. Once we have the minimum number, we'll sum its individual digits. Finally, if this digit sum is even, we return 1. Otherwise, if it's odd, we return 0. The core challenge lies in efficiently extracting and summing digits from the minimum number. A straightforward approach involves two main steps. First, iterate through the array to find the minimum element. Then, to sum its digits, we could convert this minimum number to a string. We then iterate through each character of the string, convert it back to an integer, and add it to our running sum. This works, but converting to a string and back introduces overhead. While the time complexity remains linear due to the initial array scan and string conversion proportional to the number of digits, it's not the most arithmetically efficient way to handle digit extraction. Space complexity is constant, ignoring the temporary string. The key insight for optimization is to avoid string conversions entirely when summing digits. We can achieve this using basic arithmetic operations, modulo and division. First, we'll initialize a variable to hold the minimum value, setting it to the first element of the input array. Then, we iterate from the second element onwards, updating our minimum if we encounter a smaller number. Once the true minimum is found, we initialize a sum variable to 0. Now, for digit extraction, we enter a loop that continues as long as the minimum number is greater than 0. Inside the loop, we get the last digit by taking the minimum number modulo 10 and add it to our sum. Then, we remove the last digit by dividing the minimum number by 10 using integer division. This process effectively peels off each digit from right to left until the number becomes 0. Finally, we check if the accumulated sum of digits is even using the bitwise AND operator with 1. If the result is 0, the sum is even and we return 1. Otherwise, if the result is 1, the sum is odd and we return 0. Let's trace this with the example array: 34, 23, 1, 24, 75, 33, 54, 8. We initialize min to 34. Iterating through the array, min becomes 23, then 1, which is the smallest. Now min is 1. We initialize sum to 0. Our digit extraction loop starts. Min is 1, which is greater than 0. Sum becomes 0 plus 1 modulo 10, which is 1. Min becomes 1 divided by 10, which is 0. The loop terminates. Sum is now 1. We check if sum bitwise AND 1 is 0. 1 bitwise AND 1 is 1, not 0, so the sum is odd. We return 0. For our example array, the minimum number is 1. The sum of its digits is 1. Since 1 is an odd number, our final output is 0, which is correct according to the problem statement. You'll spot this pattern when you need to process individual digits of a number, especially if performance is critical or you're trying to avoid string conversions. Anytime a problem asks for digit manipulation, think modulo and division. Another cue is when you need to quickly check parity without branching, using bitwise operations. This optimized approach has a time complexity of O of n, where n is the number of elements in the array. The space complexity is O of 1, as we only use a few constant variables. Try the next problem, same digit manipulation pattern. If this helped, hit like and subscribe for more efficient DSA solutions.